Air doesn't normally conduct electricity, but if enough charge builds up in the cloud, it can jump the thousands of meters to the ground. But what exactly triggers that discharge remains one of nature's greatest mysteries.
That's an active area of research, knowing at what point that is. It's actually very hard to take measurements of lightning within storms, and that's something that we're still working on.
The team needs that cloud-to-ground discharge of electricity if they're to achieve their mission. So far, they've chased storms for hundreds of kilometers.
Is there another one?
Yeah, big one right there.
God dang it.
They've avoided getting struck by lightning
Be careful, lightning. Just get in the car.
and survived extreme weather. They've even captured stunning cloud-to-cloud lightning on camera.
That's beautiful.
But they still haven't got what they came for. Super slow motion images of iconic cloud-to-ground lightning bolts.
Three, two, one, go!
But today, the weather balloon is picking up some promising data.
We can see the temperature's going down. The environment looks really primed for storms, and we're already seeing some really nice convective storms here.
But time isn't on their side. The storm season is almost finished for another year. They're heading for a storm 80 kilometers away. The clouds are towering above them over 10,000 meters high, and they look laden with water and ice. Could this be the electricity generating machine they've been looking for? Will it produce the elusive cloud-to-ground lightning? And if it does, will they be able to capture it? The super slow motion cameras are soon ready to catch an event that usually lasts just a fraction of a second.
I've got the camera running at 100,000 frames a second right now. And I do hear a little bit of thunder in the background.
Suddenly,
Oh! Oh! Oh, did you get that? There were 3 of them.
Got it.
Dustin thinks he's captured something.
Oh my God. That is amazing.
Go, do it again. I want to do it again.
Do it again, do it again, do it again.
Do it again, do it again.
In real time, the lightning bolt is just a flash. But Dustin's footage reveals the cloud-to-ground strike creates several pathways through the air.
That was badass. So it was the first time I've ever seen lightning like at that speed and like that resolution. It was insane. It was unreal.
When one of the pathways reaches the ground, all the electricity is discharged. And with nothing left to drive the other pathways, they vanish.
That stuff you almost don't see with your naked eye that bright.
Never
You see a
have.
quick flash and you have no idea it looks like that. That's amazing. Oh, that is a good bulb.
It's a fantastic first result,
Sad I was switching lenses.
and Jeff's struck it lucky too. His camera records much slower than Dustin's and reveals even more detail.
Oh, nice.
Nice.
Very cool.
The iconic lightning bolt we see with the naked eye is in fact a vast electrical charge traveling upwards from ground to sky.
I've never seen anything like that before.
That's the part that hurts. You don't want to be around that.
The moment the team feared would never happen is finally here. It's showtime.
Oh! Oh, God! Oh!
Got it? Oh, nice.
What a great spot.
I got
Let's
that one.
go! Oh, that's a good one.
But they haven't completed their mission. And as day turns to night, there is one last image that the team is still desperate to capture.
We'll drop it in this way first.
This is just the opportunity Jeff's been waiting for, to use his light-splitting filter.
Oh yeah. Oh yeah. Yeah, that looks good.
It's the first time Jeff has tried it on a color slow motion camera.
Wow, that's really awesome.
It reveals yet another surprising secret that can't be seen with the naked eye. The vivid colors that make up the white flash.
So you can see the big return stroke over on this side, and then the spectra is over here.
Jeff can use the different amounts of each color to calculate the temperature of each individual lightning bolt. The more blue, the hotter it is.
Say 25 to 40,000 degrees Celsius for the return stroke.
Well, that was incredible. And I love seeing all that. Oh!
Oh!
Oh! That was good! Holy! Nice!
Success! The team has achieved everything they set out to do.
Whoa!
Oh, nice. Oh, wow.
Boom!
Oh, that looks great.
Their mission is complete,
This is a great last night.
Awesome.
and they've given us a ringside seat at the greatest display of electrical power on our spectacular Earth.